Okay, so yes, graphing absolute values. All right, let's refer back to what is called the most basic form. All right, the most basic form of absolute value. Does anybody remember what it was? What does it look like, absolute value? All right, let's just say we totally forget. What's the absolute value of 0?
0.
All right, what's the absolute value of 1?
1.
What's the absolute value of 2?
2.
Absolute value of 3.
3.
All right, so everything to the right is this line right here. All right, now please listen because this helps for your understanding. All right, what's the absolute value of -1?
1.
What's the absolute value of -2?
2.
So it just forms what shape? It shapes, yes, it is a V. All right, what I need you to understand is that, now watch, this is y equals x, right? But what happens when you do the absolute value? All of the negatives become what? So the answer would have been negative, but you just move it to what? Positive, right? So that's why it creates the shape of a V. This line right here is really y equals x. And this line right here is y equals what? Negative x. That is correct. That's why when I told you when you're graphing y equals absolute value of x, you can break it down into a piecewise function. All right, when you break it down to a piecewise function, it's y equals x for anything greater than or equal to 0. And then it's what? Negative x for anything less than 0. All right, so this again is critical. All right, that's just the graph of y equals negative x, and the right side is y equals x. This right here, guys, is called the parent function. All right, and we say the parent function is just the most basic form. All right, the most basic form. All right, now last year when I taught you quadratics, we had something like y equals a parentheses x minus h squared plus k, where h comma k was the vertex. All right, I'm not expecting you, we're going to review that next week. But anyway, hk is called the vertex. So you're supposed to remember this is shift left or right. And the K is the shift what? That is correct. Shift up or down. And then A is considered to be the vertical stretch if the absolute value of A is greater than 1, or it's a vertical shrink if what? The absolute value of A is less than 1. Now, what in the world does the absolute value of A greater than 1 mean? That means if A is greater than 1, or if A is less than what? -1. If the absolute value of A is less than 1, that just means A is less than 1, but greater than what? -1. All right, meaning anything between -1 and 1, and this would be from -infinity to -1, and from 1 to infinity. All right, now again, all of that's fancy lingo. All right, I'm just trying to show you. That's not something really to write down. Honestly, that is something to understand. All right, if you understand it, it's very simple. All right, if A is greater than 1, it's a stretch, and I'm going to demonstrate what the stretch is. All right, if A is between -1 and 1, it's a what? It's a shrink. All right, and again, that's in comparison to the parent function. All right, in comparison to the parent function. All right, so everybody needs to know what the absolute value of X looks like. If you understand the parent function, then you can graph all other graphs. All right, so what exactly does that mean? All right, so let's get into the real problem now. All right, notice here, I want you to describe the translation. All right, so what's inside, notice y equals a absolute value of x minus h plus k. Does everybody understand this is negative h? And when I said the vertex would be h and k. Notice the relationship between negative h and h. They are what? Opposite signs, right? So this, I would like everyone to say, is just a shift what? Right, how many? 2. And then we say it shifted down what? That's exactly correct. All right, then I'd like for you to be able to say, if I shift to the right 2 and down 4, then that is the vertex. So the vertex would be 2 comma negative 4. All right, 2 comma negative 4. All right, now notice a in this case is equal to what? 1. So there is no vertical shrink or vertical stretch. So let's look at this real quick. So 2, negative 4, plot that point. That is considered the vertex. So then from there we go up 1, over 1, up 1, left 1. And then we just graph. And then we graph. Now take out your handy dandy calculator. Under Y1. Let's go ahead and hit math. Move to the right one. Absolute value should be the first choice. Then type in x minus 2, jump outside the absolute value, then do minus 4, and then hit graph, and it should be there. All right, math, hit the math button, then go to the right one, and it should be number, and then it should be the first one, absolute value. Just, okay, so if there is a problem with your calculator, you always hit zoom standard. All right, zoom standard gets you back to normal. All right. Now, the only reason I'm showing you how to do that on the calculator is because you're going to forget something. All right, I want to show you the power of your calculator. All right, does anybody have any issues graphing the absolute value? What?
I have a question. So why do you graph the line on the left? Since A is positive, why do you go up on the left?
Because it's an absolute value graph.
Um,
You with me on that?
Yeah.
Ruffin.
So what do you do after you do x minus 2? So x minus 2.
Then you go outside the absolute value and type in minus 4. And then you hit graph. And some of you guys have your window messed up, so you just go to zoom standard. Also, you might get it. Sorry. What is so, oh my gosh, let's not start this. All right, so yes, I was just getting ready to say, please turn the stat plot off. You can go y, yeah, go above, right? Hit y equals and then go above and turn it off if you want. Or the stat plot is second y equals and then it says turn on or off. You with me on that? Okay. I prefer, yeah, Davis, just if you're gonna do that, show him. I don't want you to do it. I don't want you to do it. I want him to know how to do it. I want everybody in here to know how to use their calculator. Shh.
So is A like the slope?
Yes, A is kind of like the slope. All right. A is kind of the slope. All right. So with All right, so with question number two, all right, this is just shift what?
Right one. No, left one.
Left one. And the nice thing about it, these translations are for all graphs. All right, all the translations are the same. So this is shifting left one. So the vertex is what?
1, 0.
Say it again. -1, 0. Now what's A? 1. So that's kind of like the slope. So it'd be up 1 to the right one and up 1 left one, and then just draw the graph. Number 3, what are we doing? Up 1. It's outside the absolute value. If it's outside the absolute value, it affects the up and down. So here the vertex is going to be what? 0, 1. Then from there we go what? Up 1 to the right one, up 1, left 1, and then drawing the graph. Simple as that. And I always tell kids, check your answers, plug it in your calculator, look at it, make sure you're correct. All right. I'm trying to find something here a little bit different. Okay, here we go. Jump down to number 7. All right. Shift what? Right 2, down 2. So everybody goes to the right 2 and down 2. All right, plot a point. That is the vertex. Now, the negative in front, I want you to remind yourself, we say that just is going to reflect over the x-axis. All right. Now, essentially what that means, instead of going up, it's going to go what? It's going to go down. So instead of the slope being 1, the slope is, so from there you go down 1 to the right 1, down 1 to the left 1. And now you draw the graph. And there you have it. Okay, now let's look at number 11. Everybody look at number 11. Okay, so shifting which way? Right 2, up 4. 1, 2, 3, 4. That's the vertex. Now the slope is what? Up 1 to the right 2. And then we say up 1 and to the left 2. That's what we're doing, guys. Now, I want to show you, because originally I had said it's a vertical shrink because it's less than 1. Does everybody agree with that? So why is it called a vertical shrink? So here's what the graph is supposed to look like. Please look now and watch so you can understand. That's what the normal absolute value would look like. Does everybody agree with me? So now does everybody understand why we call it a shrink? Because each point has been reduced by a factor of, guess what? By 1/2. Exactly. All right. Every y value was multiplied by 1/2. All right. Everybody good with that? All right. So now if I talk about number 12, that's a vertical stretch of what? 4. All right. So here we're going to go where? Right 1, down 1. And then from that point, I'm going what? 1, 2, 3, 4 to the right 1. 1, 2, 3, 4 left 1. And then there you have it. Now, again, I'm just for my own, normally it would look like this. The normal absolute value graph would look like that. So you're supposed to understand that each y value was multiplied by what? by 4. That's why it's called a vertical stretch. This point was stretched way up here. All right. This point right here was stretched all the way up here. All right. Anybody have any questions? All right. And I am sorry to say. Now look, all kidding aside, all of this should be done. Every problem on this worksheet should be done. All right. So that's what you're finishing up. That's all I got. All right. And then Monday, Tuesday, Wednesday, I've just got SAT problems and review problems for chapter 2. And we're doing very good. All right. Anybody have any questions? Nobody? All right. I mean it, guys. Finish up.